Hello, everyday statistics, and welcome to lesson 2.2. We're going to be talking about relationships between two quantitative variables today. So essentially what we're going to be doing is creating scatter plots and describing them. So the first thing we need to do in order to make a scatter plot is to distinguish between explanatory and response variables. And then we'll go through the process of making a scatter plot, and then we'll describe it. This is what a scatter plot is. It's got a relationship between two quantitative variables. We'll get into how to determine whether one is a response or an explanatory variable. And this is all stuff you've seen before, just a little more vocabulary. So here's what a scatter plot looks like if you had forgot. And so this one, it makes sense, right? That the weight of a diamond, sorry, the weight of a diamond determines the price, right? Not the other way around. So it makes sense that you would put weight as your x-axis and your price as the y-axis. And we'll talk about that. Your x-axis is your explanatory variable, and your y-axis is going to be your response. So we'll call this our explanatory, and then this is our response variable. All right, and then just one more thing before we move on. In algebra, you're used to seeing these called your dependent and independent variables, right? So this one, your explanatory variable, same thing as the independent variable, and this was called your dependent. So just some different vocabulary there for you. All right, so these are the steps we'll need to follow to make a scatter plot. We'll go through these steps at the very end of the lesson as we make, as I do an example for you all. If you want to put these in your notes, that would be fantastic. We'll just follow these steps as we go through it. If we're going to describe a scatter plot, you need to include all of these. It has to have direction, form, strength, and you need to talk about outliers or anything that falls out of the overall pattern, right? Some extreme values. So remember, if you're being asked to describe, in order to receive full credit, direction, form, strength, and extreme values, you have to include all of those. So let's just get right to it and make one of these things. So we're looking at the relationship between the amount of sugar and the number of calories in some movie theater candy. So we've got 12 different types of candy, and we are going to go ahead and make a scatter plot to display the relationship between sugar and the number of calories, and then we're going to describe the relationship. So let's get to it. All right, so first thing we need to do is determine our explanatory and response. What are those variables? So what I want to know is what is causing, it's almost like a cause and effect. We're trying to think, hey, does sugar affect the amount of calories, or does calories affect the amount of sugar? And we're being asked for the relationship between the amount of sugar and the number of calories. So I would determine that our explanatory variable is going to be our sugar, right? And where that's our x-axis, right? And then our response variable is going to be calories. That is going to be our y-axis when we graph this thing. In other words, right, if we go ahead and create these axes, right, and they must be labeled, right? I've got to label this, so this is going to be our sugar, and this one is going to be our calories, so just like we said. All right. So now that we've done that, we're going to have to scale our axes, right? If it's sugar, that's going to go on the x-axis, and if we come back and look at what we've got here, and let's put this on the next page so that we can look at it while we're working. And there it is. Awesome. This will help us to kind of keep track of everything a little bit better. All right, so if this is our x-axis and this is our y-axis, we're going to need to talk about the scale. So it looks like 107 is our largest value on our x. Oh, no, it's not. It is sweet tarts. Okay. So that is the largest value on our x-axis. What's the largest value for our y-axis? It looks like it might be 790. So we're going to have to figure out how to scale this properly. I think that what I'd like to do is use units of 10 on our x-axis. So that would be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. We'll cover it, right? So if these are in units of 10, 20, 30, just go ahead and put those in. And then we might have to use some different units over here on our y-axis because it looks like we're almost going to go by hundreds there, right? So let's actually do that. Let's go with oh, sure what happened there. That's better. I want to put this hash mark a little bit higher. So because we're going to go 100, 200, 300, 400, 500, 600, 700, and then 800. So we're going to go 1, 2, 3, 4, 5, 6, 7, and 8. Now, those aren't the only units that you could use, the only scaling you could use. Other scaling might be appropriate. But I think that might be the easiest way for us to do this. So now that we have created our axes and we've scaled them properly, let's go ahead and put these points in here. So let's start with Butterfinger. So Butterfinger, we've got a point at 45, 450. So I'm going to go to 45 right here, and then we're going to go up to 450, right? And we'll put a point there. The dotted lines are not necessary. I just wanted to show you, how I'm getting that, right? How I'm putting that point there. Okay, let's do it again. Junior Mint is at 107, 570. So 107, 570, just kind of trying to get that as close to that as possible. 62, 480. 62, 480, maybe right about there. And then Milk Duds is at 44, 370, maybe right about there. Yeah. All right, and then we'll just keep going on through this. 79, 790, right about there. And they're, they're not going to be perfect. They're close. But what we're going to find is a general pattern is what we're going to be looking for. We want to be able to create a pattern with this scatter plot and then describe that pattern. So I might actually just make a check next to these so that I know that I've done them. Raisinets 60, 420, 60, 420. And then Reese's Pieces is at 61, 580. And Skittles 87, 450. 87, 450, right about there. Sour Patch Kids 92, 490, 92. And then we were at, I don't know, 490, something like that. Sweet Tarts 136. Oh, we needed to go a little higher on our axis, on our x-axis. 120, 130, 140. I was looking at the other value of 107 when I was determining that. It's a good thing I was able to extend it out. All right, so 136, 680, maybe somewhere right about there. Twizzlers is at 59, 460. 59 and 460, like that. And then Whoppers, 48, 350. 48 and 350. Something like that. All right, so that's what our scatter plot is looking like right now. It looks nice. Okay, so we created the scatter plot. Now we need to talk about the relationship. Let's actually look at what the question is asking us exactly. Okay, we're just going to describe the relationship. So remember, when we're being asked to describe, we need to include the form, direction, strength, and talk about any possible outliers or extreme values. So let's go ahead and describe the direction. So when we're talking about direction, we want to know if it looks like it's a positive or a negative association, right? If the association was positive, so for a positive association, right, we should have something that looks like that. For a negative association, right, it would look something like this. If we were going to say that the association is weak, which is our only last choice, we would have something kind of like that. So this direction looks like it is positive, right? Positive direction. The form, it appears linear. If it looks something like, oh, that's terrible. If it looks something like that, right? That might not be linear. It might be something like an exponential or something like that, right? So we would look for something like that. For now, the form is going to be generally linear. The strength. So if we have, so very strong, it's going to look like that, right? And I had showed you that a weak association, right, is going to be kind of just all over the place. It's not like you couldn't draw a line connecting the points as best you could. There's not really a way to do that. So we would describe this strength as fairly strong relationship between our explanatory and response variables because it looks like if I was to draw a line that I try to get that line closest to as many points, I could, right? It looks like it kind of fits in there. And so that's why we would describe that as strong. And so now let's talk about outliers. Um, it looks like this point is a possible outlier. It has super high amount of sugar and a super high amount of calories. So the outlier we would say is the sweet tarts. Appears to be an outlier. Yeah, it's going to appear to be an outlier. And so there you have it. That's what you're going to need to be able to do for our lesson 2.2, create a scatter plot, and then describe the relationship between your explanatory and response variables by describing the direction, form, strength, and if there are any possible outliers. So there it is. We have done these things. Fantastic. Thank you guys so much for watching. I hope you're having a great day. And if you're not, I really hope it gets better. Thanks.